Most of the major advances in housing technology really got their start in the custom home market. Custom home builders who build beautiful homes like this one are typically the first to adopt new technologies. Well, one of those high-quality technologies is closed-cell spray foam insulation. Consumers today are very interested in energy efficiency. Well, with me today is Mark Joseph, who's with Honeywell.
Hello,
and Mark,
Steve.
you guys make some of the components that go into closed-cell spray foam insulation.
Yes, Honeywell manufactures the chemicals that are used as the blowing agent and insulating gas within closed-cell spray foam. So the blowing agent actually helps the spray foam rise, and then those millions of closed cells trap the insulating gas, which gives it its high R value.
Now, spray foam insulation has actually been in our home in a number of ways, in a number of places for years.
Yes, for many years it's been around. It's in most refrigerators today because of the high R value. It's the highest common insulator used. They use that in refrigerators because you want to get the maximum interior space and minimize the outside so you can get it through doorways and other fixtures. It's also, as far as foam is used in many cushions and other types of things within the home.
Another thing it's used for is to stop air infiltration. We may have remembered going to the hardware store or home improvement center and buying a can of the foam to spray around pipes and penetrations to reduce air infiltration in a home.
Absolutely. It's used in a lot of common air sealing applications today. And now, as you mentioned, in higher end custom homes, it's used much more in whole house applications.
Now, this product is really gaining in popularity.
Yes, it is. And the reason it's gaining popularity is because of many of the features that it offers. It's really not just an insulation product, it's a building envelope product. And we're going to use this demonstration in a few minutes to demonstrate some of the properties.
Okay. Now, another reason why it's gaining a lot of popularity is because it's got great soundproofing properties, and it's also very durable. It's not really affected by water or moisture.
No, it isn't. It does very well with moisture control, both with bulk moisture and with vapor, water vapor pressure. So it has a permeance of less than 1 perm. It also, with bulk water, it is unaffected. Bulk water will run off of it. So in applications when it's in the wall or in a ceiling or in a roof, if bulk water comes in contact with it, it actually kind of ties the whole roofing system or the wall together, making it one piece of wood rather than multiple pieces with multiple penetrations.
Now, for years now, this product's actually been used in commercial buildings as the roofing material, and then they just spray a coating over the top of it, and so it'd have to be pretty water resistant.
Absolutely, and that's exactly it. It really does combine multiple applications in one, not just insulation, but also an air barrier, a vapor retarder, and a bulk water barrier. And then, as you said, it has very high structural strength. Up to 3 times it can increase the frame strength of a normal 2x4 stud wall.
Now, looking at homes today, when people buy an insulation or build or use an insulation, they want to use one that obviously has a real big bang for the buck in terms of its R value, high R value, has the ability to reduce air infiltration, and that's really what this demonstration can show us, right?
Exactly.
Can you walk us through it?
Sure. And we'll turn it on. And basically what it shows here is, I'll just kind of walk you through, is what we have is cellulose, fiberglass, and Enovate, which is our brand name for the chemical that we provide as the blowing agent in insulating gas.
This is the spray foam.
This is closed cell spray foam here. What we have down here is a simulation of a warm outside temperature. So we have a fan blowing in hot, dry air, and as you can see, it's 102 degrees and 16% relative humidity. We turned this on a few minutes ago to kind of warm it up. And then what you'll see is how is that temperature transferred through these products. Because what we have is about a 2-inch hole drilled into the bottom of these plastic dividers in all 3 of these containers. And so what you'll see is, number 1, air moves very easily through fiberglass insulation and cellulose. So even though they may have a certain rated R value, if you're not blocking airflow through a wall, they're going to lose a lot of that rated R value because air robs it.
Absolutely. We call that wind washing. When air blows through the insulation, it scavenges away heat and reduces its effective R value, and which makes the wall colder or warmer depending upon winter or summer, and reduces the performance of the insulation pretty dramatically.
Absolutely, and it's very easy to get 1 to 2% air voids within a commonly built wall. OSB or whatever sheathing you use, it doesn't fit perfectly together. You have to cut holes, and you might cut a square hole for a round plumbing penetration. So there's a lot of penetrations to fill, and spray foam really does that for you, because when you spray it, it expands to fit. So it does a lot of that work, and air seals the cavity.
So what we have here, we have 3 different types of insulation. This is cellulose, basically ground up newspaper, which is commonly used in attics and sometimes in walls. Obviously fiberglass, which everybody has a good understanding of, used in attics and walls. And then of course we have the spray foam. So what we're seeing here is very hot temperature or hot air here, and this heat is basically being forced up through the air and the heat through these different types of insulation. We can see here the ping pong ball is rise to the top, right?
Yep. Absolutely.
And the same situation here with the fiberglass.
Right. And as you can see with the closed cell spray foam, it completely seals the 2-inch hole that's below it, so it's not communicating a lot of the heat through the foam itself. And as you'll see, here's the room temperature right now. It's about 73 degrees and 47% relative humidity. So just so you know, on the gauges, the lower number is the relative humidity and the upper number is the temperature. And as you can see in the spray foam, it's 79 degrees. So it's really only gained 6 degrees from the indoor temperature, even though it's got 108 degree air blowing against it. Versus the fiberglass, which is at 88 degrees, so that's up 15 degrees, and the cellulose is at 86, so you're looking at 14 degrees. So that's quite a bit versus just a 6-degree temperature ride in the closed cell spray foam.
Absolutely, insulation's doing its job.
Absolutely.
So Mark, you have some samples of different types of spray foam here.
Yes, we do. And let me turn this off.
Well, first of all, we have some open cell spray foam. Want to talk a little bit about that?
Sure. Open cell spray foam does not contain the blowing agent and insulating gas that Honeywell provides. It actually has air as the default insulator. So its R value is very similar to that of air, and which is really what's trapped in these other traditional insulations like fiberglass and cellulose. So the R value is about 3.5 per inch. Versus the closed cell spray foam that we have here, which has Honeywell's insulating gas, has an R value of about 6, because the hydrofluorocarbon that is the insulating gas is a higher R value than air. Much like in double pane windows, they have argon filled in there because argon is a better insulator than normal air.
Yeah, also it's important to note that when you say it's an R value of 6, that actually ranges anywhere between 6 and almost 7.
Yes.
And I think you're referring to an aged R value?
Correct. Aged R values. Initial R values are much closer to 7, but they usually take about a 6-month aged R value because that's the long-term averaged R value of what it will really kind of come to initially. But once you get to about 6 months, then that's the R value that we have to report when we use these.
And that doesn't change over 5 years or 10 years. It pretty much
very little. It
remains
pretty much
steady.
baselines at about 6 months, and then the insulating gas that Honeywell provides is non-ozone depleting, and it's EPA approved, so it's a very friendly, gas for use in installations like this.
Yeah, and right off the bat, you can certainly feel the difference. I mean, this is very dense.
Right.
This is about 2 pounds per cubic foot. Which is how much it weighs.
Yes.
And this product, which is the open cell, is obviously it's not nearly as dense. What is this?
Right.
Typically per cubic foot?
It's about a ½ pound per cubic foot, and you can compress it a little bit, so it's pretty easy. It's about the consistency of a sponge or something like that.
And it doesn't have much of a memory. It doesn't come back.
No, it doesn't. It's not like many other foams that are, say, used in cushions or things like that where it bounces back.
Correct.
And, in addition, this is actually a good air barrier. Both of them are. The differences come in, as you just demonstrated, structural strength, where, again, this can, increase shear strength in a wall up to 3 times. This doesn't increase shear strength in a wall measurably. Also, the water and vapor characteristics are very different, and we touched on them a little bit before. At about 2.5 inches, this actually will qualify as a vapor retarder, where this, it's much more open than that. So you can't use it in, say, cold climates as a vapor retarding membrane in addition to some of the other functions.
Yeah, this would have, for 2.5 inches, have permeability of about 1.
About 1,
which is
exactly.
basically a measurement of how easy it is for moisture vapor to trans through a material. And this, of course, is a fairly vapor permeable. It allows moisture vapor to pass through it. And also, it also tends to store water, where this would not.
No, this will definitely shield water off of it, just like in roofing applications on a flat roof. It's going to actually, let the water allow it to run off. Usually you'd put a coating on in a roofing application. And it's also, as far as FEMA, grades insulations and other materials as far as being acceptable for a flood zone, and only closed cell foams are acceptable as a FEMA flood zone material.
It's because they're so water resistant.
Correct, and it would be this or a rigid foam type of materials, but this, because it's so open, wouldn't be acceptable.
Now, another property is we touched on earlier was sound transmission characteristics.
Yes.
90% of the sound gets through 10% of the cracks. So if I can do a good job of sealing all those cracks and gaps, my house is going to be a lot quieter.
Absolutely. You walk into a spray foam house, whether it's open or closed cell, and it's going to be a much quieter house because all those gaps and cracks that occur during common construction, these foams will fill those gaps.
Now, what about cost?
Well, cost, it's a little bit more expensive than common insulation materials, but then you have to take into consideration some of the other things you can take out of construction. For example, when you do a real good job of sealing up a building envelope for air impermeability, you can reduce the HVAC oftentimes up to 25%. So you have to make sure that you get the right size HVAC and heating, ventilation, and cooling, for the house once you have it very airtight. In addition, you can take wood out of the structure because with an R value of 6 or 6.5 per inch, you can get to R19 with just a normal 2x4 stud.
Yeah, and that's important because a 2x6 system can cost you $3,000 to $4,000 more per house.
Absolutely. So this allows you to go to smalling framing members, which 2x4 studs have plenty of strength as far as, compressive strength on a building. They're generally used oftentimes just because they have to get that R19 to meet code.
It also gives you a greater square footage in your house because 2x6 walls take up more interior space.
Absolutely. And there's a lot of other things that this can help you eliminate. A lot of the caulking and air sealing and other things you have to do to get rid of those gaps and cracks, that's eliminated with closed cell spray foam.
Yeah. And of course, we always want to make sure that we recognize that homes are made of thousands of pieces put together by hundreds of people. So
Right.
the quality of the installation and having redundancy in our building makes a lot of sense. We want buildings that shed water, keep the heat in, aren't affected by moisture.
Absolutely. And I mean, the long-term durability is really something that helps this stand out. Where other insulations that are less rigid can shrink over time, or if you have a wall leak, they might get saturated and they'll leave that 1% to 2% or more air voids because they may shrink or pull away. That's very easy to get to that 40% energy losses, which that's all it takes is 1% to 2% air voids to get to 40% energy losses. So it doesn't take much.
There's certainly been a tremendous interest in consumers to build greener homes, and certainly energy efficiency goes a long way to helping homes be greener. For every kilowatt hour of electricity, for example, that you use to heat or cool your home, that's a pound of greenhouse gases.
Absolutely. This really can improve the greenness of your house. We have case studies showing energy savings from 30 to almost 60%, so it really does help you. And in addition to that, it's going to improve the comfort of your home, the strength, and the durability, so it's really a great solution.
Well, Mark, good information. Thanks for being here.
Thank you very much.